All right. So just talking about what the word complex means. It's a set of both real and imaginary numbers. Okay. Fundamental theorem of algebra. I told you not to write this down. All it means is if I have an x cubed, then I definitely have 3 zeros. That's all it means. Okay. So that's all you have to write. Linear factorization theorem says the same thing. If I have an x cubed, I should be able to write that as 3 linear factors, x minus, x minus, x minus, whatever those solutions are. So not a big deal. But the fundamental theorem of algebra, we're going to talk about as we keep finding zeros of situations. I want to see. There's the thing where I talk into. Okay. And then I showed you this yesterday. We don't have to write this again. Synonym for these things. A solution or a root is also a zero, another name for it, and it turns into a factor. And for a graph, it's an x-intercept. Okay, so all these things are related. Things have little differences in each case, but that's what goes on there. And then just a real quick review on I numbers. So I threw this down real fast. This section will be approached the same as section 2.4 with the possibility of having imaginary solutions. So some things to recall. First things first, again, I'm just the informant, or your last year's teacher was the informant. Somebody decided back in the day, hey, this isn't possible, but you know what? Let's make it a letter. And then someone said, let's call it I. Great. Maybe I, and then we'll call them imaginary numbers, and that's why we'll use I. I'm just being the informant. Okay, and then as a reminder, that's going to be a big deal. I squared, we already did this, by the way. This was in chapter P, actually equals a free -1, a real number. All right, so just to remember that. And then one more thing, because we will be talking graphically quite a bit about these. When you dealt with this, it was with parabolas. All right. And 3 things could happen with a parabola. Let's just call it a parabola going up. You could have 2 x-intercepts. Those would be 2 real solutions, 2 real zeros. You could have 1 x-intercept where the graph bounces off the x-axis. You already got quizzed on that, by the way. You already know this, right? All right, we had to do that and understand that. But that's a multiplicity. I should say 2, but I actually said multiplicity even. It could be more than 2. It could be multiplicity 4, 6, 8. But then the real deal, you could have a graph that does not hit the x-axis. That means you would have 2 solutions that are imaginary. And now that's where this section's just slightly different than the last one. Okay. All right. So I do see a few people writing, so we'll leave that here for a moment. So these are all approached or tied together here. Reminder of what an I number is, then a reminder of what an I number does for actually graphs, and if they cross the x-axis. Quick question. I to the power of 3, what was the statement? We don't really need that right now. Yeah, we don't need that, so let's not worry about that right now. Okay, don't go beyond that. Let's focus and stay in a tunnel here of tunnel vision of what we're doing. Okay, now you don't have to write this down either, but maybe you should. Actually, I lie. Maybe you should. And you know why I cross this out? Sometimes the book is so wordy, I don't understand what they're saying. And that's why don't write that. Here's what the complex conjugate zeros theorem says. If an I number is a 0, and I wrote it in typical I number format, A plus BI, is a 0, then A minus BI must also be a 0. I should add, if the polynomial has real coefficients, which all of our polynomials will have real coefficients. I'm not going to give you a polynomial with imaginary coefficients. There's also something called the complex conjugate theorem, which says the same thing about radicals. Complex conjugate. Oh, no, that is, I'm sorry, the radical. That is the complex. Sorry, the radical conjugate theorem. Radical conjugate theorem. I was could have put conj and then theor or th. All right. And that means if like 1 plus root 2 was a 0, then 1 minus root 2 would have to be a 0 as well if the coefficients are rational. And we'll never give you a polynomial with irrational coefficients. Nobody know what I'm talking about. Coefficients are numbers in front of a variable. Okay, so keep these two things in mind as we continue on to the notes. And there's going to be two things we're doing today. One is exactly what we did yesterday. The other one is actually what you did on your quiz, which is good factors are what? 3, 2, 1, go. Foil. They're going to be foiling again. I love foiling. Okay, and then here we go. You're going to foil right away. So I think I do 2, and I assign maybe 1 and 3. I don't know. I forget what the numbers are today. Yeah, we're in 2-5, so I think I picked a few from each section. I kept the homework's only 8 questions tonight. Hope that's reasonable and at least gets you to do what I'm asking you to do here and be successful. Okay, so in exercise 1 through 4, write the polynomial in standard form and identify the zeros of the function and the x-intercepts of the graph. I'm not going to do that. Okay, I'm just going to write the polynomial in standard form. Okay, fine, I will. Identify the zeros. The zeros are -2, and then they're root 3i and negative root 3i. Here we go. That's a conjugate pair. That's a conjugate pair. So that's the zeros. What are the x-intercepts of this graph? Only -2, 0. The other I numbers do not translate into x-intercepts. So that's why I kind of stopped myself and said, all right, maybe I should, just to reiterate. Are those golf clubs in your shirt? Nice. Cool. Where'd you find that shirt? Nice. It's a Lockport shirt then? Cool. Whew. So I'm waiting. Okay, now I'm ready to go. Remember, I called you a fool? You call me a fool all the time, Mr. Sand. No, I don't. I said you're a fool if you foil these two first, right? It's foolish. You make yourself, and some people did, and I'm sorry. I got to go there. I got to say it. Because you should multiply these two first, because those are conjugate pairs. What happens to the middle term in the FOIL, everyone? 3, 2, 1, go. Cancels. So those that know that just go right to here and skip even doing the lines for the middle term. And that's smart. All right. Negative root 3 times root 3. People mess this up all the time. If you really want to do it and keep it in roots, then it's root 9. You take the root 3 and the root 3 and multiply them together and still keep them underneath a radical. And then I times I is I squared. Well, here we go. What is root 9, everybody? 3, 2, 1, go. 3, and then, what's I squared, everybody? 3, 2, 1, go. -1. So do I have to write this, or can I, as a cat student, can you handle this? That becomes +3, and now it's real. Okay? Now, why did I not write the middle term? Because this is the opposite of this. These cancel. And as a cat student, we should be able to do that. We should be able to handle that. I'm not writing that. Right? And that's where I do some skipping of steps because we need to become efficient as we progress mathematically. So we make this a little bit more because I think maybe you didn't do this in Math 3. And I forgot I got Math 2ers in here. So Math 2ers, this is probably brand new. But you're just foiling, right? So we got to handle these new things. And, your teacher said you should be in here. So I think you should and be able to handle this stuff as I do little shortcuts here, make this work faster. And hopefully you can see and follow my lines. And that is the function. Okay, so the first couple examples, it's going to be foiling. We're going to be multiplying out. Can I move on? Y'all caught up? Good to go? Everyone fine? I feel like there's a lot of people missing today. 1, 2, 3. That's it? Okay, I guess it's only 3 people. Absence is a killer. I hope you're watching a video at home. All right? All right. Well, 4 and 2i are zeros. All right, write a polynomial minimum degree in standard form with real coefficients whose zeros are listed. So we don't have to say anything other than just do the polynomial. Well, of course, if 4 is a 0, what is a factor? 3, 2, 1, go. X, come on, x minus 4. And then if 2i is a 0, what is a factor? X minus 2i. Wait a minute. For this to have real coefficients, and if 2i is a 0, what else has to be a 0? 3, 2, 1, go. No, I have plus 2i, so I also have to have negative 2i. This has got to come out of your brain. I'm a jerk. I didn't give you the other 0. Oh, right. Then if 2i is a 0 and I'm going to have real coefficients, then negative 2i has got to be a 0. That means x plus 2i is a factor. X minus negative 2i. So this is something I will do to you. I'll be a jerk. I'll make you know the complex conjugate zeros theorem and have to know that that other 0 actually works. This is going to happen a few times to you throughout the next few sections. Fool, right? Fool, okay? You got to go here and take these two. Rah! You got to take these two and multiply them. Conjugates, x squared. And then I'm ignoring the middle term because I'm in cat meow. What's 4i squared become? What's minus 4i squared become? Everyone, 3, 2, 1, go. Plus 4. Everyone just said 4. That's good. But make sure you're keeping this a polynomial. And then now I can bring down that x minus 4. So actually, you should enjoy foiling with I numbers. Except when there's some nasty ones. I'm going to move this work over here. X cubed minus 4x squared. The reason I'm going in this order is because I want the terms in order descending. And I know I can mess with my lines here and do this in a little different order to write these in descending order. I guess I should put f of x equals and then circle that up. I know I'm missing some other questions. I just got to think. All right. I know what I was thinking. They should say of minimum degree with a leading coefficient of 1. They really should say that in these directions. Because if it said leading coefficient of like 7, all you would have to do is put a 7 in front of here. And then the 7, leave it until the end, and then you could distribute it. So they really should say that. But a little shortness on the directions there, I believe. It actually is. It's not that I believe it. It is definitely a shortage there. Oh, no. Now here we go. In exercise 13, to write a polynomial function of integrated standard form with real coefficients whose zeros and their multiplicities are also listed. Oh, you're going to hate this. So f of x equals, and this is x plus 2 with multiplicity 3, which means that's cubed. And then they really shouldn't say multiplicity 1. I would hardly ever write that. I'd just say, and then 1. And then there's no multiplicity listed at all. It means it's multiplicity 1. So multiplicity 3 means cubic. By the way, this is how this graph would look, just as a review of your quiz. Here's negative 2 as an x-intercept. Here's 1 as an x-intercept. If I multiplied this out, this would be a positive 1x to the 4th. So it should end like this. Remember the polynomial dance? End up and up. It should end up like this, maybe with some character in the middle. So how does that work here? Well, I'd have to come here, but then the multiplicity 3, 0, it comes through like a cubic. Then it comes up through here and goes up there. So that's just a little review. That'll probably come back at you. Not on our 2425 quiz, but when we get to the test, and just to remember that. But remember what we had to do. We have to put it in standard form, which means multiply out. FOIL. Oh no. So we're going to have to write this out and then take it a step at a time. Now, again, I'm not going to say this is difficult. It's just lengthy, and you got to be careful. This is really separating, the strong cat students with the ones that don't want to put that work in. And then you should be able to be a good foiler that 2x plus 2x is 4x. And then this is you want to get nuts? Let's get nuts. Okay, so again, x squared and then 2x and 2x is 4x, and then 2 times 2 is 4 at the end. Now I might use colors. This is x cubed. This is 2x squared. And I'm going to do this and tell you what you need to do here, what I see people doing that's a little goofy. What I see people that are a little bit goofy, they don't combine those like terms, and then they start multiplying by x minus 1. That's a nightmare. 4x times 2 is 8x. In doing this, I'm getting my like terms right next to each other, too. This is nice. 4x and 4 times 2 is 8. I'm not going to listen to anyone that says this is difficult. It's just lengthy. There's a difference. Okay, so this is x cubed plus 6x squared plus 12x plus 8. But this is like the infomercial from heck. But wait, there's more. Now I got to multiply by x minus 1. Are you okay? You just made a face. Yeah. Okay. So here we go. Oh, Lord. You know what I'm going to try to do? I'm going to try to do colors and well, we'll slow it down. There's x to the 4th. There's negative x to the 3rd. This is going to be a mess with these lines. There's 6x to the 3rd. That'll be easy to add those together. There's negative 6x squared. 2 more to go. There's 12x squared. So much room for error here. You got to be careful. That's why I draw the lines and go a step at a time. There's 8x. And then there's negative 8. What a nightmare. You never did that in Math 3, I bet. That's where cat and Math 3 separate a little bit. So f of x equals that. And then these added together is 5. These added together is conveniently 6. These added together is negative 4. And then that is just negative 8. Oh, that's a rough one. How many people had fun with that one? Nobody. Okay, good. Everyone all right? Big yawn there. Okay, now it's to the next phase. This is exactly like yesterday. Okay, find all of the zeros. So you were given the zeros, you had to find a polynomial. Now you have the polynomial, you got to find the zeros. It's a complete and complete reversal. Okay, and then write a linear factorization of the function. Ooh, so basically you're going to write this in factored form after you find the zeros. Okay, well, we're going to go to the graphing calculator. Oh, give it a second. It always takes forever to open up. There it goes. We'll wait. Okay, sounds good. Good plan. You probably will because this calculator so takes forever. But you know what? Usually he very well might beat me on this because usually they're nice. Usually 1 or negative 1 is a 0 or 3 and negative 3. Huh? Okay, well, we're still going to do this, okay? All right, so it's still going to happen. Okay, this is the point where you have to give up and say, all right, Mr. Samus is going to do his thing still. Yeah, see, but you're still not understanding, okay? Shh. What a year this has been in 6th hour. 44x minus 69. Okay, and then graph, and then boom. Oh, it's 3. See, you guys? All right. All right, so we got it. We got it all by ourselves. Okay, so now, and then notice that graph. I don't know if I had to zoom. I wonder if I zoomed. Let me see this again. Zoom standard? Boy, that's a crazy. I think I am Zoom standard too. This is nuts. So I don't know what that graph's really doing, but it looks like it's bent this way. So it might come back down. I'm gonna just listen. Zoom, and then I'm gonna go zoom out. No, yeah, I'm gonna try that. And then press enter, show you some features. Boy, I really don't know what's going on with this graph. Now it looks like it's bent this way. Did I type that in correctly? Yeah, I guess I did. I'll work on that later. There is like messing with Windows to try to find out what the graph actually looks like because I should see a cubic look. I should see this, and I couldn't even see the shape on that. What actually was going on? Understanding what's happening. But I got what I needed. I got what the zero should be: 1, -10, 44, and then 69. And then 1, 3, -7, -21, 44, 34, 24, 23. And it is. Did I do something wrong? Oh, I did. Well, yes, I did do something wrong. I didn't write a negative there. Good. And then I knew it should have been a zero, so I knew I'd made a mistake somewhere. I forgot to write -69 or -69. Okay, does anything multiply to 23 and at the same time add to be 7? Yes or no? 3, 2, 1, go. No. So what do we have to do? The opposite of b plus or minus the square root of b squared minus 4ac. Get ready. All over 2a. We sing it every time. All right. And then equals, go to your calculator. 4 times 23, 80, 92, right? 92. 49 minus that, 50 minus 92 would be 40. So is that 43 negative? Is that negative 43? What a weird answer. Well, you know what's nice about that? 43 is prime. So I don't have to bust anything out of that. So this is 7. Oh, but by the way, what's the square root of negative 43? What must I write? I root 43. Or you could write root 43i. I just like writing it in front. If you have a teacher that tells you one way is the right way, they're wrong. Some sticklers out there. Okay, now, what's the matter, huh? Yeah, root 43, then put the I on the outside to the right is okay. Now, remember what it said. Find the zeros and then write a linear factorization. So here's the linear factorization of it. 3's nice. That means x minus 3 is a factor. This is not, but this is how you're going to write it. X minus, you probably should put brackets around this now. I'm going to use parentheses. And you could be lazy like me. X minus 7 plus or minus I root 43. Because I think this is silly to do this, but this is what they're asking. Boom. And that actually counts as 2 other factors. But that's the rule. If a 0 is a 0, a factor is x minus that 0, right? You can do that on the test. I don't care. If you get transferred to another cat teacher, they may be sticklers and say, write them both. Okay? All right. Is this the last one? Oh, of course not. All right. Oh boy. Here we go. Let's see if you can beat me on this one. Okay, then by the way, I don't know if I showed this yesterday. I showed I kind of got discombobulated on the x to the fourths yesterday because they were a little bit too challenging to find those zeros. And then I went to my calculator and used the find zeros feature. I have a better way. I'm going to show you that right now. Don't tell me I'm going too fast because this is so slow for me to use my mouse to try to type this in. Plus 3x. What's the matter? What's wrong? Oh, -2. I'm not racing. I don't care. Okay, I don't care. Okay. Or wait, did I ever go through this with you? Didn't care less. Remember that from last year? Don't you or no? Okay, by the way, I've zoomed out, so I got a zoom standard 6. And then hopefully these stick out pretty good. Oh no. But what does that look like? What does that look like right there? What does that look like? -2. What does that look like? That actually doesn't even look like a half. That looks like it might be a third. And you know why I know it's a third? Because 3x. I bet you one of my factors are going to be 3x minus 1. I bet you that's going to be one of my factors. So I bet you that's a third. So what do we say? -2? Now, this is important. I just caught someone doing this, and I want you to just to make a point. Sure, we're going to synthetically divide out that 8 and prove it's a 0. It was -2, right? Well, we'll find out, right? 3, -2 times 3 is -6. -2 times -4. I'm going to make sure I don't make a mistake. -2 to -4. I'm looking good here. -1. And then this is 2, which is 0. So, yes, what I saw checked out. So I know, and then I'll prove this is 1/3. Sorry, I said I was going to do this, and then I didn't. I did something different. I don't think I did this yesterday. I added a y equals 0 because that creates a anyone a horizontal line, and now I can go to my second calculate, and instead of doing 0, which I really fast did a left bound, right bound, and you're like, wait, hold on a minute. I don't have to do all that crap. I can do an intersection now because I have two graphs. And then I could go closer where the 0 is. This is just another feature. I almost wanted to say a dumb feature. I don't like it, but there's the first curve, move by the 0. Second curve, great, hit enter. Guess, whatever, hit enter. And then it finally says intersection. What is 0.3 repeating, everybody? 1/3. Okay, so I did want to show that. I didn't want to skate over that. But here's the problem. You don't go back to the original and synthetically divide a 1/3 out of that. You go to this depressed polynomial, which is now an x cubed. You knock this down from an x to the fourth to an x cubed, and now you want to knock it down to an x squared. All right. So, and then this column's over because I have a new polynomial I'm dealing with. I don't want to have to rewrite it. I want you to understand that. For an x to the fourth, you got to double depress it. All right. So first rule, drop the 3, and then this isn't hard. 1/3 of 3 is 1. Well, look at this. 3. 1/3 of 3 is 1. Well, look at this. 3. 1/3 of 3 is 1. It was 1/3. It does prove. And now I have something even goofier I have to show you. But it comes to writing the linear factorization. But let's continue and find the remaining zeros. By the way, what do all of these have in common, which is obvious? 3. So actually, I'm going to divide out a 3. And then does anything multiply to 1 and then those same two numbers add to be 1? No. So here we go again. The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay, and then this becomes -1 plus or minus. This is square root of -3, which is root 3i, or I root 3. So that's nice. I don't have to do any simplifying again. Okay, but remember what it said. It said write the linear factorization. We got a problem, folks. See, this is supposed to multiply out to equal the original. So -2, this is good. X plus 2. Do not write this next thing down, but watch. Do not write this term down. Do not write this. Or write it and then cross it off like I'm going to do, because that is wrong. X minus, sorry, let's put brackets. And let's do the cheating thing that we did before. By the way, if I recall the back of the book, they don't write this correctly when they ask for a prime factorization. So just look for the zeros. I think there's a mistake in their, if I remember correctly. I've dealt with this book for years. But here's what's wrong with this. What's x times x times x times another x, because there's actually two factors in there. What's x times x times x times x? 3, 2, 1, go. X to the fourth. It's not What x to the fourth? Say it. 3. So this factor is wrong. You need to write that as 3x minus 1, which also gives me a 0 of 1/3. Do you see what I'm saying? All right. So that's why maybe that's a better way of teaching. Show the wrong answer, then replace it with the right answer to connect with the original question. Okay. It did happen here. It's because synthetically dividing by 1/3, that is from a factor you don't know, 3x minus 1. But when you solve for x, you get 1/3, and then there's this problem. That's one of the problems with synthetic division. It is. In a way, it can cause confusion. And then here's an awesome one. I love this one. Love it. And then when I give you a worksheet tomorrow, there is a section where we do give you one of the zeros. So you don't have to go searching on your calculator. By the way, on your calculator, would you be able to extract 3i as a 0 by looking at the graph? Yes or no? 3, 2, 1, go. No, because this is not a what. It's not a what. It's not a x. Help me. It's not an x. Anyone? Intercept. So we got to do something. All right. So in exercise 33 through 36, use the given 0, find all of the zeros, and write a linear factorization again. Okay. Well, first of all of these coefficients are real. So I'm going to scroll back up to here to this complex conjugate theorem. Complex, I kind of cut that off, but it is in here, and I wonder if I can erase it. Yep. If all of the coefficients are real numbers, it's within there, then they must come in conjugate pairs. So going back to this, I'm a jerk again. Well, you're a jerk all the time, Mr. Samuelis. I gave you 3i as a 0, so what absolutely also has to be a 0 if all of these are real? Negative 3i. So now you have 2 zeros. Okay, so we're going to prove it. No whining. We're going to prove 3i is a 0. 1, 4, 11, 36, 18. What should I get at the end here? What should I get right here? No, what should I get here? 0, and I should get what here? Yeah, and then we'll see that happen. Okay, so let's have it happen. Well, first step's easy, 1. Great. Second step's easy, 3i. Now this is when the stuff hits the fan, so to speak. What's 4 plus 3i? First of all, is it 7i? Yes or no? 3, 2, 1, go. This is where I start. This is where the goofiness comes in. That's not a cat issue. That's what you walked in here with. All right. I got to get you to understand it. It's not like I'm trying to, I just hear people, oh, cat's so hard. But then the mistakes they make are not cat mistakes. I get this goofiness. Oh, now we got a problem. How do I take this times this? What do I have to do? It starts with a D, and I have no time here. Distributes. So maybe do your work off to the side if you can't think about it, which it is kind of hard to think about this one. That's 12i. You know what? I'm going to write that over there because that's not a like term with 11. And then 3i times 3i is 9i squared. What does 9i squared become? Negative 9. So I'm going to write it like that. So that's why I gave so much space here. You're going to want space. This becomes 2 plus 12i. Don't have a conniption fit yet. It does take some time. Wait till you see the next step, though. I'm going to get rid of this because this is in the way. All right, and then take 3i times 2 plus 12i. This is why this is cat. We extend things that you may have known from Math 3. And if you came from Math 2, you got to get on board on this right away. All right, and you will. It's not really that hard. You just got to remember these steps. That's 36i squared. What's 36i squared, everybody? So I put, well, look at, are you kidding me? Negative 36 plus 6i. That becomes just 6i here. And then take a wild guess what 3i times 6i is. It is negative 18. So I know I'm doing well. And then that's the only hard part. Because now watch this. What is this called? It starts with a D and a P. A depressed. This is actually 1x cubed now. This is the term for x squared. This is the term for the x, and then this is what I call the constant, what everyone calls the constant. So what do we got to do? Well, those are imaginary coefficients. That's because I told you if 3i is a 0, then negative 3i must be a 0. Watch how easy this is. So there's really only one bad series of steps, and it's in the first thing. Bring down the 1. Negative 3i times 1 is negative 3i. Well, how convenient is that? Negative 3i times, well, how convenient is that? And then, yes, there's proof that the conjugate was also a 0, double depressing this polynomial. Get ready, because does anything multiply to be 2 and then add to be 4? Yes or no? Anyone multiply by 2 and the same two numbers add to be 4? Yes or no? 3, 2, 1, go. No, nobody answered. So here we go again. The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. A tragedy if we still have a senior that doesn't know the quadratic formula. Tragedy. Okay, and then this becomes negative 4 plus or minus. I think we got the square root of 8 on that, right? And then negative 4 plus or minus 2 root 2 over 2. If that was too fast, 8 is 4 times 2. The square root of 4 is 2 free. And then guess what? This reduces even more to be negative 2 plus or minus 1 root 2. 2 goes into all three of these. And then to write a linear factorization, this is what we could do. F of x equals, it was just 1x to the fourth, right? Linear factorization would be x minus 3i. I guess we could have done plus minus because I'm doing that on the last one. Plus 3i. And then let's be lazy. Let's put a bracket and then do x minus parentheses negative 2 plus or minus root 2 because they asked me to. So I found the zeros. To write a linear factorization is one more annoying step. That's why I don't care about writing the minus 2 zeros at once on the last thing. So do understand that is 4 factors. This counts as 2 of them. All right. Fundamental theorem of algebra. If I have an x to the fourth, I have 4 zeros. Right. So that's why we got to make sure we understand that. I think in our questions yesterday, you ended up with a 2x squared plus 2. Does anyone remember that happening in your notes yesterday or homework? Then subtract 2, divide by 2. Why am I going over this? When you square root, what is this final answer? Plus or minus I. How many zeros is that? 2. In that question, you should have got 4 zeros. When you don't put plus minus, you lose a 0. All right, so I just wanted to make sure you understood that in context of the complex conjugate theorem. Okay.